How would you describe the winter this year? Normal, icky, or super icky?
Super icky.
Super icky.
Mm-hmm.
All right, thank you. It was a most unscientific survey, asking the most obvious question.
Super icky.
Super icky. All right, thank you.
You're welcome.
But the sun was out, the temperature hovered near 50 degrees. It was the first mild day the folks in Asheville had experienced in months. And so it was the perfect day to pose the question on everybody's mind. How would you describe the winter this year? Normal, icky, or super icky?
What is icky, though?
You're an icky? Okay. How about you?
Super icky.
Super icky.
Too much snow.
All right. What about you, sir?
I'd say normal, but I'm from Pennsylvania.
The gentleman from the Keystone State was the exception. It's not surprising that labeling the past winter super icky won hands down in my survey, which I conducted near the National Oceanic and Atmospheric Administration's National Climatic Data Center. The folks inside know a thing or two about the weather, so just what kind of winter was it?
The thing about this winter is really unusual compared to recent winters. When you compare it only to the 21st century winters, it was really cold in the east and it was really snowy in the east. But when you extend that record backward and you start looking at the late 20th century and the middle 20th century, this winter doesn't seem so unusual. We've experienced several winters like this in the past.
It seems we have short-term weather memories. The past winter was unusual, no doubt, but not all that unusual when you look back over 30 to 40 years of weather data. The scientists at the center also say the fact that most everyone thought this winter's weather was so unusual is proof. We are getting used to shorter, warmer winters, which come with a slowly warming world.
It's a key thing to note. Winters are changing in the U.S. and around the northern hemisphere, and we don't experience this type of winter as often as we used to.
As the world gets warmer, the long-term climate trend is for winters to be warmer and shorter, and summers to be hotter and last longer. But climate scientists note the daily weather can still change.
But what we have to deal with every day is the weather, and the weather still moves hot and cold air around like it used to before the world was warming. And so understanding what's the relationship between the ingredients that drive today's weather and climate, and the relationship is how often do those ingredients come together now.
Think of it this way. The man walking his dog represents all of us. The dog is the day-to-day weather. The incline is the world's temperature, and the hill represents climate. As our everyman and his dog progress through a world in which the temperature is gradually rising and the climate warming, the dog still moves around. The daily weather still changes. Everything is still warming, but the weather goes back and forth. In short, climate determines what clothes are in your closet and whether you buy a certain coat. Climate is long-term. Weather determines tactical decisions, such as what coat you will wear on a particular day. But let's go back to our recent winter. Scientists call it an exception. So what type of weather can we expect to see? In general, the climate trend is for winters to be warmer and shorter, while summers will be longer and warmer. Scientists say rain and snow events will be different as well.
The big change for precipitation is not so much how much precipitation a place is going to be getting, but how the mix will change over time. That what we're seeing currently, and we're seeing it around the world, an increase in heavy precipitation, and that goes very much along with climate theory, that your clothes dryer warms the air in the dryer because it can evaporate the water more quickly because warm air can hold more water vapor. So when you have a warmer air, you have a potential for the air to hold more water vapor. So when something does trigger a storm, such as a cold front coming through, there's a greater chance that it's going to have more water vapor in the air and therefore a heavier precipitation event.
Bottom line, scientists say areas won't get more rain or more rain events, but the amount of rain that falls per event will be heavier. A warmer world will also bring more heat events, such as extreme droughts and fewer cold events. The warmer, wetter atmosphere could also generate more severe storms. All of this climate projection is based on an analysis of massive amounts of data. The Asheville Climate Center collects almost 4 petabytes, or 1 million gigabytes of weather data per year. It's collected from weather stations and airports, weather observers, and satellites. It's enough information to fill 20 million 4-drawer filing cabinets per year. It's all available to the public, and scientists hope people will use the information in planning for a changing climate.
Because we have to know where we are to know where we're going in terms of weather and climate. So we get a baseline of conditions each year, and then we look to the future with the benefit of models.
Adaptation to climate change also adapts us better to our current environment. And adapting to our current environment adapts us better to climate change. I mean, it's the change that impacts things, because our ecosystems and our cities and our built environment are all designed for the climate of the recent past, not the climate we're moving into.